This problem is what I call a matching problem because we have an expression here and an expression here. These two expressions are equal, so what we do is something I call matching. So if we're trying to solve for the individual values, what we can do is try to expand these formats so that we can get the same constants first. So 3x times ax gets you 3ax squared. 3x times negative b gets you 3xb plus 4ax minus 4b. Now we can use something called matching, where if these two expressions are the same, we also would know, therefore, that the individual values are going to be the same. So that means that negative kx is equal to negative 3xb plus 4ax and 16 is equal to negative 4b. So we can take that a step further. 24x squared is equal to 3ax squared. We can cancel out the x squared, so 24 is equal to 3a. So a is equal to 8. For the second one, we have negative kx is equal to negative 3xb plus 4ax. We can't do anything there yet, so we'll get back to that. And we also know that 16 is equal to negative 4b. That means that b is equal to negative 4. Now let's plug in all these values and solve. So we have negative kx is equal to, we can also first, let's get rid of all these x values. So we divide both sides by x. And now we're left with negative k is equal to negative 3b plus 4a. Negative k, therefore, is equal to 3 times negative 4 plus 4 times 8. This gets us negative k is equal to 12 plus 32. That means that negative k is equal to 44, which also means that k, if we multiply both sides by a negative 1, is equal to negative 44. Therefore, the answer is A.